Okay guys, let me explain in more details about the negative feedback for homeostasis mechanism and explain a little bit more about this loop. In the book you have different kind of samples about this loop. I took the time to develop mine that I will apply in several chapters that are coming. First of all, in which one are the components? And you mentioned, you read in the book and you read in the PowerPoint that the components of this loop are the sensors, the control center or integrating center, and the effectors. Okay, this one is a loop. How these play a role? We have a main player that is the central nervous system. The central nervous system is composed by the brain and the spinal cord, and is considered integrating center. Everything goes and passes through the central nervous system. The other players are the receptors and the effectors. The receptors or sensors, we have several and different type of receptors in our body. If we are talking about homeostasis, homeostasis is talking about our internal balance. Nothing else, nothing more. And it's tremendously difficult to keep our internal balance in internal environment in balance. It's really very it's a very hard work that lasts 24/7. Every single minute in or second in our life, our internal environment are using all the different homeostasis mechanisms to keep that internal environment in balance. If that internal environment is not in balance, we develop an illness or disorder. What kind? There are different times and they are affecting different systems. But let's replay a little bit more. That receptors or sensors are the ones that capture the deviation from that particular range. And I want to be focused that we have, as you read in the PowerPoint, that we have thousands of different values that are considered essentials, and our internal environment will fight with everything they can in order to keep them in balance. For example, the blood pH, or the blood pressure, or the blood volume, or the glucose levels for any electrolyte level. And we consider electrolytes sodium, calcium, magnesium. Sodium is a big word, is a capital letter. So the balance between sodium and water is tremendously important. But we have another electrolytes, like I mentioned before, magnesium, chloride, calcium, potassium, and even more. So for all and hormones, at least we have in the pituitary, we secrete 9 hormones, and we have another different glands that secrete another different hormones as well. So for any single hormone, we also have a normal level. And this normal level is expressed in 2 numbers, a higher number and a lower number. This one is not an average, it's considered a range. Now, let's finish to develop this one to explain the action of one of the 2 hormones that you have to be very familiar with. In this loop, we have the receptors, and that receptors, also called sensors, are the ones that sense the deviation from the normal of that value, whatever it is, one of the one I mentioned before. This change is sensed by the sensors or receptors. Those are using, that change is using the sensory or afferent neuron that is considered an input that sends the information to the central nervous system. Sometimes that change happens in the central nervous system itself. It doesn't matter. It's using always sensors or receptors and always using a sensory neuron to inform the central nervous system what is going on. That central nervous system is considered the control center, integrating center, it doesn't matter, is the main center. It's the one that is using interneurons, and interneurons from anatomy, if you remember, are the largest amount of neurons we have in our neural system. These interneurons are always located in the central nervous system, considering that could be a brain or the spinal cord. But certainly these interneurons are the ones that capture the information coming from the afferent neuron, afferent or sensory. The interneurons are the ones that are catching that information and passing to the next level, that is the motor effector. These interneurons are also not only the one that capture the information, they capture this information and they have to decode it, they have to analyze, they have to read it, what is happening. Okay, that information when it's decoded and is analyzed is the information that one is clear what is happening. Now is clear which one is the action that need to take place in order to fix it. That action cannot take place by the interneurons because they never leave the central nervous system. But the interneurons are using another player in this game that are the motor or efferent neuron. It's efferent because it's leaving the central nervous system, and also it's called the output. But certainly this motor or efferent neuron is the one that will reach the effectors, and the effectors are the ones that fix the situation. Sometimes the sensors and effectors are located in the same place, and most of the time the receptors and effectors are located in different places. Also, in order to fix one of the values that I just mentioned, either hormones or blood pressure or blood volume or heart rate, the values are tremendously high, is very large list about it. But certainly, in order to fix that deviation of this value, sometimes they use only one effector, and most of the time they use in several effectors. It's not black and white. But certainly this one is the loop for negative feedback. And I want to emphasize that there are a few samples of positive feedback. And I want to talk in more detail about those later on. Now that you have that explanation about that loop and how they are acting, let's talk in more detail about one sample. And you can use any sample. You can use the values of one hormone or the values of blood temperature or the values of glucose levels. The list is unfinished. I want to mention before to jump in the next topic that the effectors, and listen, homeostasis is defined as the balance of our internal environment. So most of the factors are involuntary. It doesn't mean that all of the factors are involuntary, but most of them are involuntary. And which one could be? Any smooth muscle, anything that is involuntary to us, is not under our desire how to fix it. So if that one is the case, most of the time we use the autonomic nervous system. From the nervous system, we use the autonomic. Why? Because we use either the sympathetic or the parasympathetic in order to reach that effectors. And these effectors could be the smooth muscle, could be any gland, could be any organ, any vessel, and also the heart, because a heart is one of the organs that is obviously 100% not under our voluntary control, so it's totally involuntary. Now, let's jump into one sample specifically about the glucose level or homeostasis control of the glucose level, and keep in mind which one is one of the normal range. And pay attention, a range is not an average. A range is considered what is the normal value we can have about this particular molecule, and which one is the lower number we can have about this the same molecule. And in between, which one is the highest and lower one, that everything in between is considered normal value for this molecule. For glucose, the normal value is between 110 to 75 milligrams per deciliter. Now, milligrams per deciliter is the same that milligrams per 100 milliliters. Now, in these two plain solid lines, I said what is the range for glucose. That is 110 milligrams per deciliters as the maximum normal level, and what is the lowest normal level is considered 75 milligrams per deciliter. I want to also clarify that these numbers are not absolute for all the labs. I mean, in certain labs, the maximum amount of glucose could be 100 and the minimum could be 75 or even 74 or 73. So are not absolute numbers. Every lab is working with similar numbers, but there are a little difference between Quest Diagnose with corporate labs or the different labs we have around. In between this number, any number that we have in between is considered normal. And in your book, you read one word that is called set point. And this set point is any number in between the highest to the lowest one. I also mentioned that my set point doesn't have to be your set point. We have different individuals. We are different, and also that values can be different. What is a normal set point for other patient could be totally abnormal for me. But in order to measure if my set point is normal or not, we need to refer to that normal range between 110 to 75 milligrams per deciliter. Now we have the set point. Let's pretend that I'm going to keep myself in the spot, so this one is my set point. It could be a little close to the highest one, or it could be closer to the lower one, but it doesn't matter. Meanwhile, is in between these two numbers is considered normal. Now, what happened with the glucose level? Immediately we wake up. After we wake up, and I'm talking about a normal patient that doesn't have or is not diagnosed or under treatment for diabetes, either one or two. So in my case, I not have any kind of disorder that affect my glucose level. So after I wake up, my glucose levels are normal. And immediately after I take a meal, and this one is the cross that I take a meal. At a certain point, I take a meal. Could be a solid breakfast or could be a lunch. But certainly, when we have that meal, absolutely, in any meal, and obviously it depends with your habits, in little more or little less, we have certain amount of carbohydrates. when we digest that carbohydrates in our abdominal area, by digestion, we increase the glucose level in the bloodstream. By increasing the glucose level, that level of glucose in myself after a meal increase, and reach the highest number. When reach the highest number and even above that higher number, right here is when the sensors is detecting that level of glucose that is above the normal. When it's above the normal, it's using that afferent or sensory neuron and inform the central nervous system. The central nervous system analyzed the situation and decided to send an order to be taken. And this one is taken by the motor efferent neuron that reach, this one is the efferent motor neuron, and that motor neuron reach the effector. The effector in this case is the pancreas. And the pancreas is the one that has the islet of Langerhans, containing the alpha cells and beta cells. In this case in particular, the motor neuron or efferent is reaching the pancreas, and specifically is instructed to stimulate the beta cells in the pancreas to secrete insulin. Now, insulin is released as a hormone, is released in the bloodstream, and the target of insulin is all the cells in our body. All the cells without exception. Some need more, some need less. But with insulin, our cells are capable to take the glucose from the bloodstream and use it, any single cell in our body, to produce ATP. Now, when insulin is released, that insulin is producing the glucose levels to go down to normal. And is the measurement that many patients are taking, measuring the glucose levels 2 hours after the meal. After 2 hours, the glucose level should be in the normal level, right here, in the normal level. However, let's pretend that that meal was during breakfast and we have a very light meal during lunch. But we still have to continue working, thinking, moving, everything from that point on until we have the next meal. When we continue working, moving, exercising, running our normal day that is really very intense in general, we consume all the glucose that was in the bloodstream, in the normal bloodstream that we achieved to bring in from higher level to the normal level, to my set point. And after a few hours that I continue even blinking, my glucose levels go below the normal because we consume all the glucose, normal glucose level, and the glucose level go below the normal. When that glucose level, in my case, reach below 75, is again sensed by sensors. And these sensors are the one that, again, the sensors are the one that detect the glucose level, inform the central nervous system with using the sensory afferent. The central nervous system decode it and use the motor efferent neuron to reach the effector. And in this case, the effector is the same organ, is the pancreas too. But is targeting the different cells in the islet of Langerhans. Instead of the B cells are going to be the alpha cells. And the alpha cells are the ones that secrete glucagon. Now, that glucagon hormone is released in the bloodstream, and when it's released in the bloodstream, the target is not all the cells in our body. The target is the liver. In the liver, we have a storage of glucose in different format that is called glycogen. But the glucagon is the one that the action of this glucagon is to request the liver to break down. It's like a scissor, is cutting all that glycogen molecule in little pieces, and the little pieces that make glycogen are glucose molecules. So, by the action of glucagon, the liver releases glucose fresh into the bloodstream, and by that we recover the glucose level again. So, this action, insulin and glucagon, are obviously antagonic hormones. But this sample of insulin glucagon, that loop is negative feedback. But this also has an antagonic effect because the hormones that are released are antagonic between each other. I also want to mention that when you read negative feedback, it doesn't mean that the levels goes below the normal. Negative feedback could be that the level of that molecule can be up, above the normal, or below the normal in any of the scenarios or the values that we need to measure. But this one is a sample of the action in this particular case about the glucose levels and how that glucose level are kept in balance by the feedback loop. In case of the positive feedback, there is a little different. And we mentioned about positive feedback, 3 most important samples. Are not the only one, but are the most common one and more graphic one to explain. One of them is the uterus contraction during labor. The other one is the production of milk after birth, and the third one is the coagulation factors that are triggered when the clothing cascade, the blood clotting cascade is triggered. In this scenario, there is no negative feedback. It's not like a go above the normal or below the normal. In the case, for example, of the uterus contraction, there is a normal set point, and for different reasons that when the baby gets the point to be ready to birth, the baby is producing stretching in the uterus, that is the myometrium. If you remember, the muscle, the smooth muscle that made the uterus is the myometrium. This myometrium has sensors. There are stretch sensors or stretch receptors. When the baby is stretching that uterus wall at the time of birth, that receptors in the uterus inform the central nervous system using the same circuit, but the action is not to bring the value back to normal. The action is different. The action in case of the uterus is stimulate more contraction. And in this mechanism is more stretching, more contraction, more stretching, more contraction. But it's the way that our physiology helps the baby to be pushed out. In the case of the milk production is pretty much the same. It's very well known that we have different machines available for the mothers who just give birth. And these ones are the pumps, the breast pump. Didn't exist when I had my children. So either you have the time to breastfeeding your children, or you have to give up. And certain jobs allow you to synchronize one with the other one, especially if you were independent, or in my case, I was a dentist, so I regulate the schedule of my patient in order to allow me breastfeeding my children for maximum 6 months. I couldn't last it longer than that. But in today's day, you have the breast pump, so you can have a travel and you carry that breast pump all over the place where you go. And the benefit is your baby will receive fresh milk all the time and all the time that you want it. But basically, what is the action? When the baby born and is exposed to nursing and you breastfeed your baby, the baby is taking milk out. And that one is another positive feedback. More milk you take out from your breast, more milk your body will produce. It's not like more milk and we produce a negative feedback that we are going to bring it to the normal. No, it's not. More milk, more production, more milk is eliminated or is taken by the baby or from the breast pump. More milk is produced, more milk is taken out, more milk is produced. And in this circuit, there's a positive feedback. The mother can continue breastfeeding the baby for a longer period of time in case she has to work or they have a schedule that is not compatible with the breastfeeding of the baby. So this one is an explanation about the negative and positive feedback. I hope it helped, and I will continue with additional videos for this chapter.